Hey guys, I was looking through your learning journals and wanted to touch on one point that I think can be a little bit confusing. So it's easy to memorize the rule that charge trumps radius, and so you kind of use that as the first sort of pass, and then use radius as a tiebreaker. But I wanted to show you why that's actually a rule, and we're going to prove it today with math. Okay, so I'm going to be using Coulomb's law formula. And remember that force is equal to the force of the electrostatic attraction, which is the lattice energy in this case. Now there's a constant here that I'll write in for now, but we don't really need to think about that constant or use it right now because it has equal impact on every substance. So I'm actually just gonna get rid of it for now. Now, we can see from this formula, which is how we would correlate or quantify, I guess, the lattice energy in an ionic bond and compare two substances or more than two substances to each other. There's two variables that impact this: the charge of the substance of the ions and the radius, or the distance between the proton and the nucleus of the metal and the bonding electron and the valence shell of the nonmetal, or the anion, I guess. So I'm going to break this formula apart and isolate each of those variables on its own. So I'm going to take Q1 times Q2 over 1, and this is multiplied by 1 over R squared. All right, so what I'm going to do in order to actually prove to you that charge is more important is I'm going to hold the charge constant, vary the radius, get a number, and then I'm going to vary the charge and hold the radius constant and get a number. And we'll compare the two differences in those, okay? So the first thing I'm going to do is I'm going to vary the radius. So this is like having an independent variable, a controlled variable, and then getting a number. And this is actually a really good strategy to use like on PSATs or SATs. Just plug in fake numbers and get an answer. So this is a strategy I always recommend to my students. Okay, so the first thing I'm going to do is I'm going to keep charge constant, and I'm going to vary the radius. And I basically just make up numbers. Now, these numbers are, kind of on the order of what you would see in an actual substance, or if I'm looking at two different substances. I'm gonna make up two substances here. Substance 1 and substance 2. So these are just two different ionically bonded substances. So let's say I'm going to make the charge is equal to 1. So the charge product, Q1, Q2, is just equal to 1, just to make the math easier. So substance 1, I'm going to make sure that the charge is the same in both of those substances, like I just said, and I'm going to change the radius. So now I'm varying this piece up here, and this piece is going to be held the same. So let's say substance 1 has a radius of 387. This could be picometers, and that's squared. And the substance number 2 has a radius of 450 picometers, and that's also squared. So when I plug this in, and I actually find a value, this is equal to, and I rounded to sig fig, 6.68 times 10 to the minus 6. And this one is 4.94 times 10 to the minus 6. All right. So this is 1, 2, 3, 4, 5, 6, 6, 8. This is 1, 1, 2, 3, 4, 5, 4, 9, 4. Okay. Now, we can see the differences in the lattice energy when I vary the radius, but let's now see what happens when I vary the charge. So if I'm going to vary the charge, then I have to keep the radius the same. So I just picked, for ease, I picked 387. I could have picked 1. It's not a big deal. But so now I'm going to keep radius constant. And I'm varying the charge. All right, so this is sort of like scenario number 2. Okay, so I'm going to say that the product of substance 1's charge Q1 times Q2 is equal to 2. And I'm going to actually use that radius in the denominator. And 1, substance 1 is 1. That's a 1. And I'm still going to say that they have the same radius so that we're looking only at the impact of the charge. All right. Now I actually plug these numbers in, and this one equals, and this sig figs are not the same, but it's 3 times 10 to the 5th. And this one is obviously half that amount, 1.5 times 10 to the 5th. So you can see that the difference between this one and this one is not twice, right? Like this is maybe a third as big, and this one is twice as big. So this one, you know, we're just looking at the fact that like if I double, even doubling, that's just increasing it by a factor of 2. But let's say I did something like that was, you know, 6, then I would be multiplying this number by 6. All right. So even with a minor change to the charge, that has a much larger impact on the quantity, the value of the lattice energy than a minor change in the radius of 2 ionic substances would have. So that's sort of like mathematical justification why the charge is more impactful on the lattice energy than the radius is, and why we look at it first. So hopefully that helps. Hopefully.